Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Rocky Jude 99. Thanks for the suggestion, Rocky. You asked, why are tectonic plates constantly in motion? If you've ever felt an earthquake, marveled at a volcano, or wondered why continents look like they're drifting apart, today's the day we finally break it all down. What makes the Earth's surface shift, collide, and sometimes blow its top? So, if you've ever found yourself asking what's going on under your feet, or just want to know how the ground stays in motion, stick around as we uncover the forces, drama, and literal hot mess that is tectonic plate movement. Right here on Explaining Everything. To figure out why tectonic plates move, we need to understand what they're even sitting on. Think of Earth like a big, angry layer cake. The outermost layer is the crust. That's where you live, work, and try not to trip over the sidewalk. Beneath that is the mantle, a hot, thick layer of rock that isn't quite solid, isn't quite liquid, like pudding with commitment issues. Beneath the mantle is the outer core, which is molten metal swirling around, like a smoothie made of lava and regret. And at the center is the inner core, a solid metal ball that's hotter than your ex's mixtape. Now, the crust and the upper part of the mantle together form the lithosphere, Earth's crunchy outer shell. But it's not one smooth piece. It's broken into massive chunks called tectonic plates. These bad boys are constantly on the move, slowly gliding across the planet like giant, rocky bumper cars. And unlike most things that move, they don't need wheels. They've got physics. So, what's pushing these enormous plates around? The secret sauce is convection currents. Deep in the mantle, the Earth's internal heat causes hot rock to rise, cool rock to sink, and everything in between to swirl around like soup on a low boil. This movement creates a slow, powerful conveyor belt that carries tectonic plates along for the ride. Think of it like a planetary hot tub, and the plates are the rubber duckies caught in the current. Except instead of relaxing, they're colliding and causing natural disasters. But wait, Earth's not just stirring the pot, it's also pushing and pulling. Enter ridge push and slab pull. First, ridge push happens at mid-ocean ridges, where magma from the mantle rises up, cools, and forms new crust. This new rock shoves the older crust away on either side, like magma saying, "Excuse me, I need some space." It's a gentle but persistent nudge, sort of like your mom encouraging you to get a job. Slab pull, on the other hand, is Earth's version of a power move. When an oceanic plate gets old and dense, it starts to sink under another plate in a process called subduction. As it dives into the mantle, it drags the rest of the plate along with it. It's like when your friend decides to leave a party early and pulls you out by your hoodie. Except in this case, the party is the lithosphere, and your friend is being eaten by the planet. Where tectonic plates meet, chaos ensues. These plate boundaries are the reality TV shows of the geology world. Intense, unpredictable, and occasionally explosive. There are three main types: divergent, convergent, and transform. At divergent boundaries, plates move apart like a boy band after a messy breakup. Magma fills the gap and creates new crust. This is how the Mid-Atlantic Ridge was born, thanks to two plates ghosting each other in spectacular fashion. At convergent boundaries, plates crash together. One gets shoved under the other like a passive-aggressive roommate hiding your leftovers. This can create volcanoes, earthquakes, or entire mountain ranges. The Himalayas. Yep, that's India dramatically headbutting into Asia for the last 50 million years. Then there's the transform boundary, where plates slide past each other horizontally. It's like two people brushing shoulders in a narrow hallway. Only instead of an awkward oops, it's an earthquake. The San Andreas Fault is the king of this type of drama. California is basically riding on a fault line like a mechanical bull. Tectonic movement is also responsible for continental drift. A couple 100 million years ago, all the land on Earth was clumped together in a supercontinent called Pangaea, a massive geological cuddle puddle. But the plates had other plans. Over millions of years, they started drifting apart, slowly shuffling continents into the layout we know today. It's like Earth played a really slow game of Risk and just never stopped. And yes, technically, the continents are still moving. Your house probably drifts a few centimeters a year. Congratulations, you're on a very slow, very rocky road trip. Now you might be thinking, what if tectonic plates just stopped? Like the Earth took a nap. No more earthquakes, no more volcanoes, no more last-minute changes to the landscape. Sounds peaceful, right? Not so fast. Plate movement is part of what keeps Earth habitable. Volcanoes release gases like CO2 into the atmosphere, which helps regulate temperature. Subduction recycles old crust. Without this geologic hustle, the carbon cycle would grind to a halt. The surface would wear down, and Earth would become a cold, crusty, lifeless pancake. So, ironically, all this plate movement is what keeps life rolling. If you enjoyed this video, or found yourself surprised that continents are basically surfing on molten rock, leave a like and don't forget to subscribe. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.